think it is time. Gamers, it is time. We're going to talk about vinegar today. Literally, vinegar that you cook with. You can find this in your kitchen. I'm sure you have vinegar in your kitchen because almost every place, every person who's ever cooked has used vinegar at one point in time. So it's time to learn how this can clean amazingly well and how it's okay that it can clean amazingly well, but you can still eat it. This is almost like the real drink bleach challenge. Okay, so this question was a great question because it hints a lot on the chemistry, and I'm going to hit on that, and then I'll pick up back on chat after that. So, how is it okay that we can eat this product and also use it to clean amazingly well? Well, to start, we need to look at the chemical formula of vinegar. That's where we got to start. Okay? So, CH3COOH. C is carbon, H is hydrogen, and then the O is oxygen. So, what you see right in front of you, this right here is called acetic acid, or also known as vinegar. Let's break this down. So, if you see here, these lines, these are single bonds. This carbon right here is single bonded to a hydrogen 3 different times. And then when you have 2 lines, it's a double bond. So when you have this, these lines represent 2 electrons. So here between this carbon and hydrogen, you have 2 electrons. You have 2 electrons here, 2 electrons here, 2 electrons here. Since this is a double bond, you have 2 sets of lines, which means you have 2 sets of 2 electrons. So there's 4 total electrons in this bond. And then 2 electrons here and 2 electrons here. So electrons are really what makes the world go around. This is how we have electricity. And I kind of explained this in our battery video, so I'm not really going to hint a lot on how these electrons are working, but I'm just going to go over the hierarchy, the chemical compound of vinegar or acetic acid, which is what you see here. So according to Wikipedia, I pulled off a great reaction of what happens when you put acetic acid, which is what you see here, in water. And so when you put acetic acid in water, you get this chemical compound called acetate and H3O, which is basically water, but with an extra proton. And if you don't know what a proton is, it's basically an electron. You know how electrons are negatively charged. You learned that from my battery video. And if you didn't, you need to go back and watch it. But electrons are negatively charged, and then the hydrogen or the proton that I was talking about is positively charged. So it's just the opposite of an electron. And so when you have this reaction, you have about 95% water mixed with 5% of acetic acid. So this right here, when you have vinegar, it's about 5% of this and 95% of this. So simply, the vinegar that we clean and cook with is just a very dilute acetic acid, and it's harmless at this temperature. At this mixture, at a 95 to 5% mixture, it's harmless to us. But if you take a big whiff of 99.95% acetic acid, and I've learned this from, promise me, I know exactly what this is like because when I was working in a lab at the USDA, I took a big whiff of acetic acid and my nose was burning. And it's 10 times worse with hydrochloric acid, which is kind of like bleach, but it's like one of the strongest acids around it. It will knock you out. How does something so dilute clean so well? So let's kind of break down this reaction into the active parts, and we're going to really break it down into the acetate and the hydrogen, because these are the main ingredients of what makes this actually a good cleaner. And so in a basic sense, if you look at the hydrogen, it kind of makes sense, because when you have the hydrogen, you basically have an atomic bomb. So, like I said earlier, we have this hydrogen proton. We're going to talk about why it loves to bond. And so, as you saw in the hydrogen bomb that I just used, the example, it just loves to just create a reaction, and it can cause, in some senses, a extrapolated reaction, a reaction that happens multiple times, and then it's bad news. That's how you get a bomb. But we're not talking about bombs. We're just talking about how protons love to bond. So it'll really cling to anything you find. So if you have a stain on the floor and you pour some vinegar on it, this hydrogen is going to attach to that stain, and it's going to kind of suck it up off your carpet, because that stain is really chemically attached to your carpet. And so when you put the hydrogen on it, it's going to suck up that stain. And then you just go on with a napkin or a paper towel, you wipe up your stain, and off you go with your life. The hydrogen, when it comes down to it, it's all touchy-feely. It's like giving a big ol' hug. And so I drew a beautiful person here so that you can visualize what the hydrogen is doing and why it helps remove a stain. Because basically it's just giving a big hug to whatever you don't want, and then you just go and pick up the hydrogen, and since it's hugging what you don't want, you can pick it up as well. And so that's part 1. Okay? Part 2 is the acetate. We can't forget about the main event, because this acetate right here, remember how I was talking about how many electrons it had? It has a bunch of electrons all on this side, and I could go into a bunch of dipole moments or chemistry stuff that you don't care about, but basically these electrons right here act as a magnet, essentially. It's not necessarily giving a hug, but it's really pulling things in, and it changes the chemical makeup. So it's really good at pulling off rust and grime, and it pulls it in and adjusts its chemical makeup, and then it just dissolves in water. Since it's polar and water is polar, they dissolve together because likes dissolve like. And maybe I'll make another video, a separate video on why likes dissolve like, but that's how it works. So the acetate will pull in rust and grime, adjusting the chemical makeup, dissolving it in water. And then another thing, which is huge and why this is amazing, is it kills bacteria and fungus. And this is a combination of both the acetate and the hydrogen, because it kind of all works together from the acetic acid. But the pH, when you mix this with water, is so low that bacteria and fungus just can't survive. So after doing all this, instead of the hydrogen giving a hug, I kind of said it's like a person that wants you to die, essentially. It'll take you, it'll dissolve you in water, and then you just toss the water where you don't want it. We went through this really fast, and if you have any questions, let me know. I can pull it up. But in the end, when I said this is the bleach challenge, I'm not saying to go drink vinegar. It won't taste good, and this will really bug up your stomach acid. Because your stomach acid is already at 2.5%, and your body knows how much to produce of this. So when you put in more vinegar, more acetic acid into your stomach, it really just causes you heartburn, and you'll probably throw up. You won't die unless you drink a ton of it, but you will definitely not feel good. So don't just go drinking it. But you can easily, and you're going to love this part of the presentation because it's absolutely beautiful. You can cook with it, you can clean with it, and if you want to throw up, you can drink it, but I'm just kidding about that. So there you go. Does anybody have any questions? This is amazing. I'm so proud of these beautiful graphics, and I hope you learned a ton about vinegar. And I went through that super fast, and I know I did, but I hope you enjoyed it. I hope you enjoyed hanging out.